You've probably seen the Ouroboros, right? The ancient symbol of a snake eating its own tail. It usually stands for eternity, for endless cycles. But what if it's also the perfect metaphor for life itself? Not as some static thing, but as a dynamic, constantly self-correcting loop. Let's dive in.
I want you to just think about this for a second. What if your body, every part of it, your ability to heal, the shape of your limbs, all of it, what if it wasn't just built from a fixed genetic blueprint? What if it was actually running on a kind of biological software?
And if that's true, just think about the implications. So many things we see as permanent, birth defects, chronic diseases, catastrophic injuries, could be seen in a whole new light. They're not just flaws, they're bugs in the code. And bugs? Well, bugs can be fixed.
And it doesn't just stop at debugging, right? Because if you can find the bugs, you can go a step further. You could actually rewrite the code. You could send brand new instructions to the body, telling it how to repair damage it's forgotten how to fix. And then, here's the really wild part. If you can rewrite the code, you could potentially upgrade the hardware itself. We're talking about pushing our own biology way beyond what we ever thought was possible. Now look, this isn't some pie-in-the-sky science fiction idea. A really groundbreaking new perspective in biology is saying this is exactly how life works. So let's pull back the curtain and actually take a look at this code that builds us all. So where do we even start? Well, the first piece of this incredible puzzle isn't actually in our DNA. Nope, it's in the electricity that's humming through every single one of our cells. This is the foundation of what some are calling the body electric. You know, for the longest time, the old view is pretty simple. Our genes are the hardware. They're a static blueprint that builds us from the bottom up, piece by piece. But this new view, it completely flips that script. It says, yeah, the genes are the hardware, absolutely, but they're being run by a dynamic, top-down software, a bioelectric program that tells that hardware what to do. Okay, so here's the key concept, this bioelectric field. You can think of it as a network of electrical charges, a voltage pattern that exists across all our cells. And this pattern holds what scientists call the target morphology. It's like an electrical ghost of our final form, and it's the master plan the body is always trying to build. And if you want proof, this is just amazing. In a developing frog embryo, scientists can literally see an electrical pattern of a face, like a ghost face, appear in the tissue. And this happens before a single gene for building an eye or a mouth has even been switched on. The software is setting the stage long before the hardware even gets to work. It's incredible.
All right, so we've seen the big picture, this kind of top-down control. Now let's zoom way in. Let's talk about the intelligence of the individual parts, the cells themselves.
To really wrap your head around this, you have to totally rethink what a cell is. It's not a passive brick like tooth enamel that you just have to force into place. No, cells are what scientists call agential material. They have their own abilities, their own ancient agendas. So you can't just command them, you have to communicate with them. You have to persuade them to work together. So how on earth do you communicate with trillions of individual cells all at once? Well, it's through this amazing biological network they call cognitive glue. These are basically tiny channels that connect all the cells, letting them share electrical signals, stress, even memories. It creates a kind of cellular hive mind. And this is just a brilliant solution to that classic problem, right? The one and the many. Through this cognitive glue, all the little individual goals of each cell get merged into the much larger goal of the whole organism. They literally form a single unified self. Okay, so if bioelectricity is the software and cells are these intelligent agents running the code, well, the next question is pretty obvious, isn't it? Can we become the programmer? Can we actually get in there and rewrite the code? I love this quote because it just nails the concept. The genes, our DNA, they provide the stage. They lay out all the raw materials, the props, the actors, but it's the bioelectricity that's the director, writing the play and telling everyone where to go. So, naturally, scientists put this whole theory to the ultimate test. They took a planarian flatworm. Now, this is a creature whose genome only codes for it to have one head and one tail, that's it. But then, without touching a single gene, they used bioelectric signals to rewrite that anatomical play, basically telling the worm cells to aim for a totally different shape. And the result? 2. The worm regenerated with 2 heads. But here's the truly astonishing part. This new two-headed state became permanent. Every single time that worm regenerated from then on, it grew 2 heads, even though its DNA was still saying build 1 head. They had permanently patched the software. So how is this even possible?
Well, it's because the body is running this little feedback loop. It's called a tote loop. First, it tests its current shape. Then it compares that shape to the target shape stored in that bioelectric field. If there's a difference, it operates. It grows or remodels to fix the error. And once the target is reached, it exits the loop. That's why regeneration isn't just blind growth. It's an intelligent error-correcting process.
Okay, if you thought the two-headed worm was wild, get ready, because this next experiment is one of the most mind-bending things I've ever come across. What happens when you take cells out of this system? You take some skin cells from a frog embryo and you completely set them free from the body's top-down control. They don't just die or become a puddle of goo, they reboot. They literally self-assemble into a brand new type of organism called a xenobot. And this little creature has abilities the original frog genome never, ever specified. It can swim around, it can heal itself, it can work together with other xenobots in swarms, and, get this, it can even build other xenobots out of loose cells. It proves our cells have these incredible, hidden potentials just waiting to be unlocked.
Okay, let's just take a breath for a second. So, where is all of this heading? If we can really read and write the code of life, what kind of future are we looking at?
Well, the ultimate goal, the holy grail of this research, is something they're calling an anatomical compiler. Think of it like a CAD program for biology. A doctor could literally design a desired outcome, say, regrow this patient's arm, and the compiler would figure out the exact bioelectric signals needed to persuade the body's cells to build.
And that right there, that's the really beautiful part of this whole new way of thinking. We don't have to micromanage every single cell, which would be totally impossible anyway. The goal is just to communicate the desired result, that new target shape, and then get out of the way and let the body's own amazing collective intelligence handle all the complicated details. And that brings us right back to where we started, with the Ouroboros. We are getting so close to closing that loop, to finally understanding the code that writes us. Which leaves us all with the biggest question there is. If life is programmable and we are finally learning the language, what should we write next?